This lesson covers storage spaces, which is a new technology introduced in Windows Server 2012 and really changes the way you're going to deal with direct attached storage. I previously talked about the various types of RAID available in Box: the striping, the RAID 1 mirroring, and the RAID 5 striping with parity. But these are fairly cumbersome to manage. If a disk does fail, you have to replace the disk, add it into the RAID set, and perform a repair. I also can't fin provision storage. I can only create volumes at the size of the amount of disk I have available at creation time, and I can't really change that in the future. Storage spaces enable me to actually just add physical disks into a space. So you can see here I have this primordial group of disks. So currently then these two disks are not being used in a storage space. I can just go ahead and say I want to create a new storage pool. So I give it a name, so test pool, add the disks I wish to be placed into this, and an interesting thing will happen. As soon as I add these disks into a storage pool, they're actually going to disappear from Disk Manager. Once they're owned by storage spaces, you can no longer access them through disk management tools. I can also set these disks if they're going to be used, or if they're only to be labeled as a hot spare. So if one disk fails, this disk would then be automatically utilized. So this is now creating a new storage pool. And notice those disks have now disappeared from Disk Manager. Once I have a storage pool, and it's giving me the option to create a new virtual disk. Now this is not a virtual disk in terms of a VHD or a VHDX file. Unfortunately the naming is similar, however this is actually creating a virtual disk in storage space terms, so it's going to utilize those disks that I added to the pool. So currently you can see I have a storage pool, and this is the amount of capacity, but at any time I can add additional disks into this pool. From this pool, I'm now going to say I wish to create a virtual disk. I select the pool, and I give it a name. So I'm going to say test virtual disk. I can give it a description. And now I select my storage layout. So notice I can do simple. Simple is just going to do that disk striping, kind of like a RAID 0. I can do mirroring, so like a RAID 1. However, you'll notice it's not called RAID 1. Notice I have parity, but it's not called RAID 5. The reason is RAID 1 says this disk, its storage is copied to this second disk. With a storage space, I may have 10 disks in this pool, and I may want to create a mirrored virtual disk. It's not just going to use 2 disks from that pool and copy one to the other. It will actually spread the blocks potentially across all of the disks. So it's guaranteeing it's going to mirror the data, but not on a disk by disk basis. Same for the parity. It's not picking a particular set of 3 disks, for example. It's going to spread the data wherever it wants. So I say I want to create a mirror. I can do thin provisioning. So I can actually say, I'm actually going to create a 4 terabyte disk, and it's thin provisioning that. Notice I don't have 4 terabytes, and this is mirroring. So really I would need 8 terabytes. Now it's giving the option to automatically go and create a volume on this. So it's going to go and create a volume on this new 4 terabyte virtual disk I created. And I'll call it Big Disk. And what's going to happen behind the scenes, and we're going to be able to see this, is it's only allocating disk from the physical drives as it needs to. So initially it's only going to be using megabytes of disk space because the disk is empty. So I can see my free space is still 555 gigabytes, even though I've created a 4 terabyte mirrored disk, which would normally require 8 terabytes of data. So actually, as I write data, it's going to grow. It will start allocating more and more. This is actually one of my production servers. And you can see I actually have a storage space over here, but I use fixed. But I have 5 different SSDs added to this storage pool on which I store all of my virtual machines. The reason it's so highly allocated because it is fixed. I'm allocating all the space up front. But I'm doing parity on this. So I have protection. If any of these disks failed, I still won't lose any data. And with a storage space, all I would have to do is add another disk in, or I might already have spare disk capacity in that pool and I wouldn't have to do anything. It would just handle that failure. If it was a mirror, it would recreate the mirrored blocks. If it was parity, it would work out what data is missing. So this is really a much better replacement than the in-box software RAID we had in the past. And certainly I would advise you to not think of using the RAID 1, the RAID 5, unless you require mirroring software RAID of your boot system volume. We cannot boot from a storage space. So if you do require protection of your boot and system, you would still look to leverage the RAID 1 that's in box. But really for any other circumstance, you're better off using a storage space because of the fin provisioning, because I can expand these disks in the future, and it's just a much more efficient engine. I can also do all of this management from PowerShell. Firstly, I'd have to delete my big disk, so I'm going to delete the volume. Once that's deleted and it's refreshed, I'll actually now be able to delete the virtual disk. You can't delete the virtual disk until any volumes on that disk have been removed. So I can now delete the virtual disk, and now I can delete the storage pool. So those disks will now be put back into my primordial pool. From PowerShell, for example, I might actually want to store which of my disks can be pulled. So firstly, I'll just run it manually. So get my physical disks where they can be pulled is true. And it's those two disks. They're not currently have any volumes on them. They're not currently being used. So now I want to actually store that in a variable. So they are my physical disks, and I'm going to store those two disks. Now I can actually say, hey, go and create me a storage pool. I'll give it a friendly name. Notice it's helping me through the integrated scripting environment. Again, recommend you use this. I'll call it test pool. I give it a storage subsystem friendly name, and this name is storage spaces. In reality, other disk subsystems could integrate into this technology, but for right now, we're using the Microsoft storage spaces. So we're going to pass it the physical disks that I stored, and it's then going to go and create that storage space. So if I go back to my server and do a refresh, what I'll see is I now have my new storage space available to me. And I could then proceed to actually go and create virtual disk in there from PowerShell. Using the new-virtual disk PowerShell commandlet, I could initialize it and create partitions using new-partition as I would any other disk. As a side note, this technology is not exclusive to Windows Server 2012. Storage spaces is also available in Windows 8. As you can see here on my main machine, I actually have two storage pools, each of them with two physical drives in. One is my main data drive, and one is where I just store multimedia. So this is a great technology, and again, as I start to fill these drives up, if I needed to expand it, I could just add additional disks. I get my mirroring capabilities, so I have protection from failure. So this is certainly a great solution for your servers, for direct attached storage, but again, this is not something you would put in front of a SAN or a NAS. This is only for direct attached. SANs and NAS devices have their own capabilities, and you cannot use storage spaces with them. As you play with this technology, the fact that you can do this fin provisioning, that I can add additional disks whenever I need, and if a disk does fail, providing there is sufficient spare capacity, it will self-heal. This really is a fantastic technology to help give you a very, very strong platform for building storage services on top of Windows Server 2012.